was built on Node.js and exposed tools to perform documentation search and generate code samples for the customer's SDKs. The MCP server had two distinct parts, like most MCP server implementations out there. A MCP local server, which used STDIO as transport, and a node-based HTTP API backend to make the actual calls to the API server. Right? This was to fetch the model-generated responses from the backend. We wanted to intercept as part of the pentest and to examine what traffic was being sent. We wanted to intercept traffic between the STDIO transport and the local NPM code, and also capture the request responses between the NPM code and the backend API server over the internet. To achieve this, we created a custom MCP client that solved this for us. Running a MCP client allows for a full two-way interaction with the MCP implementation and allows traffic capture in Burp, which can then be used to perform additional testing from Burp itself using Burp tools like repeater and intruder. The MCP client has a local HTTP-to-STDIO transport proxy running on port 3000 and a local Burp interception proxy running on port 88. Proxy chains is used to send traffic through Burp while capturing both the STDIO traffic as well as the backend API calls. Let me quickly demo the client view. We run our tool. It starts the local server and proxifies traffic using proxy chains. It uses the Cloud Desktop MCP config to list all the installed MCP servers on this machine. Right? First demo, we'll choose the Hack and Use MCP server. We'll select that. Once that is selected, a local proxy is started and the list tools STDIO call is made. Right? You can actually see this interaction in Burp as well, where you can see the request that was sent to list tools and the response that came back from the MCP server itself. Now this has not yet gone to the internet. You can actually see this interaction in Burp as well, where you can see the request that was sent to list tools and the response that came back from the MCP server itself. Now this has not yet gone to the internet. This is still local. And if you're not using the setup, you'll be able to see this interaction happen at the STDIO transport layer. So we go ahead and call one of the tools. So I choose the first option. It lists the tools. I say get top stories. These are tools that are in the Hack and Use MCP server that we're using for the demo. I say number of stories to fetch, enter the count, let's say 10. I'll keep this empty. And the get top stories with arguments tool is called. You'll be able to see this in Burp, where a request was made to the Hack and Use backend, right? Getting the stories that you've requested in the MCP server. This is still local. And if you're not using the setup, you'll be able to see this interaction. You can also go back and switch server if required, and then go ahead and attack a different MCP server that's installed on your system. From Burp, now that you've captured traffic, you can go ahead and perform your other attacks possible through Burp, sending this to repeaters, sending this to intruder, your decoder and sequencer, and things like those. Right? Perform your standard backend API attacks that you can do on this MCP server, which otherwise would not have been possible if you did not capture the traffic in Burp. You can choose different MCP servers, rerouting their traffic through Burp, making this tool a universal client for